pen doesn't want to work right sometimes. Okay, so the first thing we need to do for the third problem on the L-02 of assignment 4 is the first thing we need to do is find the slope. We know we're going from 83 here to 78 down here. So let's see, let's always write our slope formula down, just so we don't get confused. So we're going to be looking for slope. And we know our difference in elevation is 83 minus 78, so it's going to be 5. Oh, pen. Might have to switch to my laptop here if this pen keeps acting up. And to figure out our length, we have to actually physically measure with our scale ruler the distance between these 2 points. So we need it printed out. I'm going to go to AutoCAD now because I have the drawing like scaled in AutoCAD, so it's kind of the same thing as you scaling it, right? So I'm going to measure the distance between 83 and 78 and get 46.8, which on your scale ruler you can round that up to 47. It's kind of hard to measure decimal points with your scale ruler. Okay, so our length is going to be 47, right? So we do our calculation. 5 divided by 47, 10. So our S is equal to 0.1064. Sorry, 0 point. And that would be, you move the decimal points over 2 places to get a percent. That would be 10.64%. And now we need that percent, we need that slope in order to figure out where this this next point is going to be. Because of this cross slope, we're not, our contours aren't going to be exactly perpendicular to these lines. So the next thing that we're going to do is we're going to take our, we're going to figure out the difference in elevation between these 2 points, and we're going to take that difference in elevation and plug it back into the slope formula using the slope that we found, and that'll give us the length that second point is moving. So we're going to do, we're going to find the difference in elevation using this slope and this length. So we have 0.02 as our slope. We need to know our DE, and we have our length of 10 feet. So multiply it both sides by 10. DE equals 10 times 0.02, which would be 0.2. DE equals 0.2. And so that's the difference in elevation, 1/5 of a foot between, between this guy and directly across the street from it. So, gosh, my pen is freaking out on me. So we're going to take this difference in elevation now and plug it back into the slope formula using the longitudinal slope. So we have our 0.1064 equals the DE, which is, sorry, that's kind of messy, 0.02, right? So we have our 0.02 over L, which we're trying to find. The L and the slope switch places, so you have L equals 0.2 over 0.1064. Break out our calculator. 0.2 divided by 0.1064. Oops. 1.88, which you can round up to, well, we'll write that down because we'll keep all of our calculations. But then when you actually go to measure it, you'll just round it up to 2. 1.88. And so what you're actually going to be drawing is you have your 83 here, and you're going to go directly across. And now that you know it's this point is moving 2 feet, or 1.8 feet, it's going to move 1.8 feet up, or we'll do 2. And we know it's going up and not down because we have our slope going here. Let me go back here. We have our slope. We have our slope going this way, and then we have our slope going this way, right? And if we kind of take the visual average of those two slopes, it's going, you know, down to the bottom left. If you were to draw contour lines for a slope that's going down to the bottom left, those contour lines would be perpendicular to the slope, right? So when you draw this contour line for this road, these lines are going to go diagonally up and to the left because the flow is going down in this direction. Does that make sense? So over here, we're going to take our line and we're going to measure up 2 feet to get to this point, and our first contour line is going to be that right there. Now, for the rest of the contours, we're going to take that 10.64%, 0.1064, and we want to find out the distance between whole number contours, the distance between the 83 and the 82, because we're going downhill. So the next contour is going to be lower, right? So we have 1 for DE, and we're looking for that L. The L and the slope switch places. L equals 1 over 1064. Do our calculator. 1 divided by 0.1064, 9.4 feet. So 9 feet you're going to measure. Feet. So you're going to go back over to your drawing, or just going to draw it. You're going to measure 9 feet down. And you're going to put that same line every 9 feet. And that's what the contours will look like for that problem. See? Does anyone have any questions on that one? Is everyone able to kind of follow along? It's just going to get harder. So it's all the same thing. It just gets more complicated each time. We're going to move on to the page 3 of assignment 4. Okay, and we're going to do, oh, sorry, was that a question?
Go back, bitch.
Okay. Scared me. It came from my sound bar up top, and I thought, oh, made my heart jump. Okay. Sorry. So we're already given the slope. We know the cross slope, which we turn 4 to 1. And we do the calculation 1 divided by 4, which gives us 0.25, right? Sorry, that's a 0, or 25%. Right. So that's our cross slope, 25%. And we're going, we're only, all right, we'll get about that. We'll worry about that later. The thing to remember is don't plug 12 into the equation. We're using 6 because we're only going to the center of the road, because like a cross section of this swale would be, you know, it's coming up and then it's coming down like that. Okay, so the first thing that we need to do is find a whole number to start our contour at, because we don't want to start at 263.85. We want to go down to 263. So we have our slope. We're going to do 0.0757 equals We know our difference in elevation, 263.85 minus 263, 0.85, and we're looking for the L. So the L and the slope switch places, 0.85 over 0.757, right? Do the calculator, 0.85 divided by 0.0757. That'll give us our distance. Come on, Ken. L equals, what was it, 11.23. Round it up to 11 for drafting wise. So we're going to come down here to our drawing and measure 11 feet down from this point. And that is where our first contour is going to begin. That'll be our starting point. That'll be 263. Right? We'll go back here now, and we want to figure out, again, the same thing, the difference in elevation. Right? Between these 2 points. So we know the slope, 0.25, 0.25. We want to know the DE, and we know the length, 6 feet. So DE equals 6 times 0.25, 6 times 0.25 equals 1.5. Quite a lot because it's a really extreme slope. 1.5 feet is our difference in elevation between these 2 points. So we're going to take that difference in elevation now and plug it back into the slope formula using this slope, okay, to figure out how far this point moves. Let's think about it. Is it moving up or down? This is essentially a valley coming away from you, right? So if you're standing here and you're looking downhill, this is a valley. So the lines are going to be coming like this, pointing towards you, because it's lower in the center, right? So, yeah. Well, okay. Sorry, guys. So we're going to plug that DE back in to the slope. We have our 0.0757 equals that 1.5 that we just got, and our L. L equals 1.5 over 0.757. Go to our calculator. 19.82. Really far. Okay, come on. L equals 19.82. So round it up to 20. So if you go back to our AutoCAD thing here, if you measure 20, you can either come across first or just measure straight from your point. I don't know if it confuses you. If you measure up 20 feet, it's going to be way off the map, but you can just draw these lines with a pencil and continue them up, so you have a point to draw to. It's 20 feet up, and you're just going to draw your line. Oh, sorry, it goes down because the arrows are pointing towards you. Just said that. Okay, so your next point is going to be 20 feet down. And you're going to connect those 2 points. And that is going to be, you're going to do the same thing on the other side, right? And that's going to be what your contour is going to look like. One of your contours. They're all going to be the same, but you're just going to move them a certain amount of feet, which we can figure out right now using the 7.57% slope, right? So you have your 0.0757 over difference in elevation of 1, and we want to figure out how far that's going. L equals 1 over, 0.757. See that? Don't make that mistake. 0.0757, because that decimal point has to move two spaces over, right? Equals 1 over L. L equals 1 over the slope. 1 divided by 0.0757, 13.21 feet. Okay, 13.21. So you can round that up to 13, and you're just gonna redraw this line every 13 feet. And it'll look something like that. You don't have to continue all the way down here. You can just cut it off, you know. Or you can just continue the lines. I know on a couple of the later ones, we would kind of continue the lines, and just so you get a couple more iterations of contours in. Yeah, does that make sense though? So, okay, I'm gonna move on. Parabolic. This is what it's gonna look like. Okay, so let's just do one of these. We'll do the parabolic crown, and that way, you know, you do one, we can explain the other. So same thing, first thing we do is find the nearest whole number. We know our slope, 9.62, so we're going to start off 0.0962 equals 0.75, 0.75, which is the difference in elevation, right, between this point and our 740, which is somewhere down here, over L, which we want to know. I always keep things in slope formula format, obviously, first, and then I rewrite them as needed, just to keep it straight in my mind. I don't know, that's how I've always, and it makes you practice.
0.75 come from the.
I'm sorry, what was that?
Where does the 0.75 come from?
0. What? I'm sorry.
0.75. Where does that come from?
Oh, that is the difference in elevation between this point and the nearest contour which we want to use, because we can't start drawing our contour at 740.75. We want to go to 740. So our difference in elevation between those 2 points is that 0.75. Okay. So to figure out how far away the first real contour is from that point that we're given, we need to use the slope and the difference in elevation to figure out the length, which is the distance between these 2 points. All right, does that make sense?
Not really.
Okay. We need a starting point, right? We could draw a contour line. We can do all of our math using this starting point, but that's not what our instructions are. The instructions are by showing the 1 foot contours. And I mean, I guess typically you could argue that you could go every 1 foot from the starting point, but really what he's asking you to do is to use the 1 foot whole number contours. So in order to actually begin doing this problem, we need to figure out where a whole number contour is. And we can do that given the information that we have, because we know where we're starting, we know where we want to be, and we know the slope between those 2 points. So we have a different.
So you subtracted the 740.75 from 740?
Right.
Oh, I didn't know that was a 7. I thought it was like an arrow.
Oh, I know. Yeah. Sorry. 740. I put a line through my sevens. It's an old habit. Yeah. So this is like our imaginary 740 line. So we're just trying to figure out the distance.
Okay.
Okay. So we have our slope and we have the difference in elevation. So we're going to find the L. And so these two just switch places. And so you have L equals 0.75 over 0.0962. 0.962. Does everyone get why the slope and the L just switch places in order, like in like the way algebra kind of works, the reason why we do that? Okay. So our length is 7.8. 8, which you can round up to 8 for your scaling. So we'll go over here. We'll measure down 8 feet. And that is where our first line will be. Right, 740. Yeah, that is where 740 will actually start. So because we're given the height of the crown, this 6 inches, we actually have to do less math now. Because if you remember, the next step here was to figure out the difference in elevation between these 2 points. We're already given. Okay, so all we're doing now is figuring out how far this point moves. It's going to be down or towards us, up or down. So let's see. A parabolic crown is like a crown, you know. So it's higher in the center than it is at the bottom. So when you're standing at the top of the hill and you're looking downhill, it would be like standing on a ridge line, right? So the arrows would be pointing away from you. Okay, if they were arrows. In this case, it's a parabolic crown, so they're circles, you know. So in which case, this point that we're trying to find is going to move up. Okay. And the distance that it moves up is, we got to take our longitudinal slope, the point 0.0962 equals, we take our difference in elevation, the 6 inches, we turn that into feet. We don't just plug 6 inches here, that would be wrong. It's 0.5 of a foot, right? Because everything else, all of our other units that we're working in are feet. You can't just plug inches into here and hope everything will work out. Equals L, equals the distance that we need to move that point up. So L equals 0.5 divided by the slope, 6.2 divided by 0.0962, 5.2. Okay, L equals 5.2. Round that down to 5. So we're going to measure 5 feet up from our point that we created. And we're going to put our next point at this intersection here. And now we're going to put that same point on the other side. And what you do to create this parabolic curve, you don't really have to worry about the shape of it. Just kind of make sure your dots are in the proper spot, and you're just going to try your best to kind of draw a little guy like that. And, to figure out where the next one is, you would just do that same thing. It would actually just be double this number. Sorry, double that, because it would be the slope, the same slope, and the difference in elevation that we're looking for would be 1, right? So you're just kind of doubling the answer, right? To prove that to you, we'll just do, instead of 0.5, it's 1 divided by 0.0962 10.4. So the next contour, wherever the 739 is at 10.4 feet or 10 feet away. So if we go back over here, we draw our line and we just draw it every 10 feet. And that's what your contours will look like for this problem. Does that make sense? Yeah, these are, and those are the other ones. Okay, we are going to move right along to probably straight to the hardest one, because once you can do this one, you can do the one right next to it. Actually, oops, wrong thing. Okay. So this is more of the same. What was that noise? So we need to do the same thing here. We're given 65.1. We're going downhill. We need to find the closest whole number, 65, right? But this contour gets kind of crazy, right? And we might run out of room. That's not what it looks like, but we might run out of room. So I'm going to go all the way down to 64. All right. So in order to find where 64 is, we take our slope, 0.05. Our difference in elevation from 65.1 all the way down to 64 would be 1.1. And our L, 1.1 equals 0.05. 22. L equals 22. So the distance here is 22 feet. Right? So we'll go back here and actually draw 22 feet down. We'll put our point. Go back here, and now what we're going to do is, oh, here, probably what we should do for clarity purposes to help us out is kind of draw the slope lines. We have a cross section going on up here. So you know the slope is going down this way, down this way, down this way, down this way. So let's actually put those slope lines just to keep us straight. Down, 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 down this way, right? Right? Okay. And then if we read, we can kind of see what our cross slopes are. So we don't know what this cross slope is, but we have something better. We have the difference in elevation, 3 inches or 0.25 of a feet of a foot. Swale, same thing, 6 inches. Shoulder has a 5% slope, cross slope, right? So it's also, it's a 5% longitudinal slope, and it's also a 5% cross slope. Don't get those things, you know, don't be confused. They're both 5%. Probably something to be, you know, tricky. It actually helps us later on, makes things easier. And then 1.5% for the curve. Okay, so we're at our 64, and we already know the difference in elevation between these 2 points is 3 inches, right? From up there, so it's 0.25. So we're going to take our 5% slope equals our difference in elevation, which is 0.25, because we're turning those inches into feet, over L, right? So that's equals 5, right? 0.25 divided by 0.05, L equals 5. So we know that the point is moving 5 feet up because we have our cross slope going this direction, we have our longitudinal slope going this direction. If we kind of visually average those two out, we know that contour lines go perpendicular to a slope, right? If you have something sloping this direction, if you're going to draw contour lines on that object, they're going to go perpendicular to the slope. Okay, so we know that this line is going to go kind of 5 feet up, not 5 feet down. And the shape of this crown is a tangential crown, which means same thing as the parabolic crown. It's just higher in the center. Instead of being round, it's tangential. It's a straight line. So you're just going to go to your paper now, measure 5 feet up, and draw your next point right here, and put a straight line between those 2 points. Do the same thing on the other side.
Bueno,
Ya te lo transferí. Saca tu cuenta.
sí, ya lo agarré.
And those are your, that's your first contour line for the street, right? So the next thing that we're gonna do, like this, right? I'll draw that a little better. So we'll go over to this side now. And because these are easy. 5%. So we're going to figure out the difference in elevation here. There's a lot of math kind of here to, it's almost kind of pointless, but if you don't know the end result, then you don't know how the math is going to turn out. Because it's 5 feet wide and we have the same slope going in both directions, you're going to end up with like a 45-degree angle. It's going to be 5 feet this direction and 5 feet this direction, and you're going to end up with just a 45-degree line, but we'll figure that out. Okay, so we're going to figure out the difference in elevation between these 2 points. We know they're 5 feet apart. We know the slope is 5%. So we're going to go 0.05 equals our DE over 5, multiply 5. Oh, sorry. TE equals 5 times 0.05. I don't know. 5 times 0.05, 0.25. TE equals 0.25. We're going to take that DE now, plug it back into the slope formula using the longitudinal slope, which is also 5%, 0.05%, excuse me, equals 0.25, it's DE, over L. L equals 0.25 over 0.05, which equals 5. So we just pull a whole lot of 5s. So you're just going to go from this point up 5 feet and put your next point at that intersection of the curb. Draw your line, and that's your contour for the shoulder. Okay. For the swale, we know the swale is 6 inches deep, right? It tells us up here. And it is 6 feet wide. So we're going to take, what am I doing? It doesn't matter that it's 6 feet wide because we already know the difference in elevation. So we're going to take our longitudinal slope, one going down, 0.05%. We're going to take our difference in elevation between these 2 points, which we already figured out, which is, or which we already have, which is 0.5, 6 inches, turn that into feet, 0.5. And we're going to look for L, which is the distance that, this point, let's see, let's draw our line here. The distance that this point is going to move up. right? L equals 0.5 divided by 0.05, which is 10, right? Divided by 0.05, 10. So if we go to our drawing now, and we measure 10 feet up from that point that we drew, our intersection is going to be at the center of the swale because the swale is going down on both sides, right? With the low point in the center. So we're going to draw our line from the last point to the new point, do the same thing on the other side. And that is what our contour will look like for the left side of the road. Okay, it's this would be like a valley if you were standing at the top of the page here. This would be like a valley that you're looking down on. So those arrows are going to be pointing towards you, the contour lines. Okay. Now we'll do the other side. Okay, so for the curb, it is the same exact 10 feet that we had from the swale. Sorry, that is horrible. Oh my God, no artist. You have your little, I have a ruler tool. Let me just use it. Oh, I can't access my tools because this thing is in the way. Go away, thing. There we go. Okay, that's what that looks like. So now for the, oh geez. For the curb, we already know that the curb is 6 inches tall, right? Curb 6-inch height. So it's the same 10 feet. This end was lower. This line went diagonally upwards. This curve is 6 inches higher. So this 10 feet is going to go downwards. Okay, 10 feet. You can kind of try your best to do a diagonal line between those two. I'm just going to guesstimate 10 feet right now. Okay, and you put your line for the curve. Does that make sense why it's 10 feet? Because it's the same calculation that's going on over here. Instead of it happening in 3 feet, it's happening in 6 inches. And I'm pretty sure they just show these double lines to kind of confuse you. Realistically, I mean, you can just draw a straight line as long as your contour goes up here, and then the rest of it is going to continue down like this. Okay, so for this next part, we know that the curb has a 1.5% slope, and it is 8 feet wide. So now we want to find out the difference in elevation between these 2 points. So we have our 0.015% slope equals DE that we want, and the length is 8 feet, because that's the width of the sidewalk. DE equals 8 times 0.015. 8 times 0.015, 0.12, sorry. DE equals 0.12. So we're going to take this difference in elevation and plug it back into the slope formula using the longitudinal slope of 5%. 0.05 equals 0.12 over L, which is the distance now that this line is going to move down. L equals 0.12 divided by 0.05. By 0.05, 2.4. L equals 2.4. You can estimate that as being 2 feet. So remember, we can I didn't do this in AutoCAD yet, so we have to come down 10 feet for our curb. Okay, there's our next point. And then from this point, we're going to go down again, right? That's 2.4 feet or 2 feet, because you guys have the scale rulers. Oops, it's a big circle. So you're going to connect these 2 points now, and you have the rest of your contour, which is going to look something like that. Okay. Right. And to figure out how, the spacing between those 2 points, you can basically take the 10 feet that we got from the half foot of rise and double that 10 foot, because we would just be redoing them after 1 foot of rise, and it would be 20 feet in between contours. So just to show you that, that would be 0.05 equals 1, because we want to figure out where the next contour is over L. L equals 1 divided by 0.05. 1 divided by 0.05 is 20. So you just go down 20 feet, which is probably actually like way down here. You go back here, take all of these and just draw them every 20 feet. And that is what that problem will look like. And you have the same, the same issues going on in the other problem. So with that, if you understand how to do that, you should be able to do a whole assignment. Does that make sense? Does anyone get lost at all? Want to go back? I'm going to stop the recording actually now, because that's a good little for assignment 4.